In 6.3, you're asked to find the domain of several different functions, and until you figure out what domain and range are and really get that solidified in your head, they can be kind of tricky. The domain, when they're asking that, is the set of inputs that give you real outputs to your function. So basically the domain are the numbers that you're allowed to plug in. So if we look at what is the domain of y equals 5x to the half, let's think about this function for a second. Now, we know x to the half power is the same thing as the square root of x. And since we're more familiar with the square root of x, I feel like it's probably going to be easier to think about it written that way as opposed to x to the 1/2. But you should know that x to the 1/2 and the square root of x are the same. Now, we know about the square root of x a bunch of different things that we can plug in. For instance, if I think of this as a function machine, and I have my function y, I'm getting my outputs y. Let's call this f, I guess, and I'll call this f of x. Okay. If I plug in, let's say, 1 into my function machine, well, we're taking 5 times the square root of 1. The square root of 1 is 1, and so obviously our output is going to be 5. If I plug in 4, I would do 5 times the square root of 4. We know the square root of 4 is 2, so I have 5 times 2. And obviously 5 times 2 is 10. So if I plug in 4, what I'd be getting out is 10. That means that 1 and 4 are elements of the domain. Now let's think of a number that we can't take the square root of, or at least not get a real number. If I tried to plug -1 into this function, I would take 5 times the square root of -1. Now we know from earlier in advanced algebra that this is going to give us an imaginary number, but it doesn't in fact give us a real answer. And so no real answer comes out, no real output. This tells us that -1 is not a part of the domain. Of this function f. So what other numbers would not be a part of the domain? Well, pretty much any negative number is going to cause us problems, and any positive number is going to be okay. We can plug in whatever positive number we like. So the domain of this function is equal to all non-negative real numbers. Now, if that's a pain in the butt to write out, which I kind of think it is too, another way to say all non-negative real numbers would be to say that x, your inputs, have to be greater than or equal to 0. So you could say the domain of the function is x is greater than or equal to 0, which is a lot less writing. Now, let's look on our graphing calculator and see what this looks like. So if I grab my calculator, and I hit y equals, and I plug in 5 and then the square root of x. I'm going to make sure my window is standard, so I'm going to hit zoom and then 6 to get a standard window. And I see a piece of the curve here. Because I only see graph on the left-hand side of the y-axis, this would tell me that my inputs have to be positive. Another place I could look to verify this is the table. So if I hit the second button and then the graph button and I go into my table, I see sure enough that anytime I have a negative input, I'm getting an error for my output. However, when the inputs are 0 or positive, I'm getting real outputs. And so that's another way to verify that the domain is x is greater than or equal to 0.